Good afternoon and welcome to the Fusion Report Forum. This is our first webinar that we're having. It's called Fusion 2035, the 10-year shot clock. We'll be joined by a number of companies that come from the Fusion ecosystem. Before we get to that, let's go through kind of what how we're going to run this. By the way, my name is Mike Heumann. I'm the Chief Analyst of Condition Research. I'm also Editor-in-Chief of the Fusion. So we're going to have a number of companies presenting today. First will be Commonwealth Fusion Systems. Commonwealth will be represented by Ben Byboth. Following Ben will be Xcimer Energy. Again, the presenter for that will be Connor Galloway. After that, we'll have Peak Nano. John Tomko is a principal product development leader. Peak is a company that builds high temperature films for capacitors, especially for fusion applications. In addition, we'll have Brian Berzin. He's the co-founder and CEO of Thea Energy. We'll also have Will Regan, who's president and co-founder of Pacific Fusion. We'll also have Alain Becoulet. He is the chief scientist and deputy director general of ITER. Finally, we'll have Oded Gorali. He is CEO and co-founder of nT-Tao. We'll also have a video from Helical Fusion, a company in Japan who sent us a short video. Finally, after that, we'll have live panel discussions and we'll have Q&A and then closing remarks. A couple of ground rules on the webinar. Again, thank you for coming to our webinar. We really think that you'll like this, that you'll find it really interesting and hopefully very valuable to you. We're going to be recording this webinar and we'll provide a link to the recording for all the registrants. If you have questions during any of the presentations, put them into the Zoom Q&A window. We'll attempt to answer all these during the Q&A after the panel questions. By the way, when you submit a question, if you have that question directed specifically to a speaker that you're asking about, please put the name of the speaker in your question. As a final notice, we won't be answering questions put in the chat window, so please put them in the Q&A window. Again, thank you for joining us. A couple interesting facts before we go off to our many different people from our ecosystem. The demand for electricity on our planet is growing at an incredible rate. Now, we're used to, at least in the United States and probably in most of the developed world, electrical demand increasing by maybe 0.5% or 1% a year, or even being flat. Okay, over the past 3 or 4 years, that trend has changed dramatically. Most of the projections out there says the demand for electricity in 2050, which you can see on this curve here, will be greater than 2x what it is today. If you look at the colored bars, this shows what US EIA's forecast was on how much electricity could be generated using current sources. So obviously we have a huge gap on that, which we call the electricity generation gap. Okay, that, as you can see, started early, it's starting to increase, and it's going to get very large by the time we get to 2250. Today, the only way we can close that gap is by burning more fossil fuel. That's to generate baseline electrical supply. And baseline, but we mean an electricity supply that can be turned on or off at any given time. If you have renewables such as solar or wind, that can only be done if they have battery systems that are backing them up, which significantly increase the cost of those systems. And that, at least in my mind, is one of the reasons why achieving commercial fusion energy in as near a term as possible is so important. Now, before we turn it over, we'll just turn it over now let's talk a little bit about some of the reasons this demand is increasing. The 2 biggest ones in the United States are data centers, which we've written about in the Fusion Report, and also the charging electrical vehicles. If you go somewhere like China, EVs in particular are a huge part of that demand increase there. Other parts of the world, it tends to be the electrification of industry, the electrification of residential cooling and heating, and commercial cooling and heating. As you can see, this demand leaves a huge gap, well over 12,000 billion kilowatt hours, which is a large amount of electricity. It's probably about 1/4 of what we'll need in that time. And with that, let's go over and turn it over to our panel. Thank you very much.